All right, welcome back, Hononegah Honors, Algebra 2. Today we're going to move into our next conic, which is section 13.3, ellipses. So ellipses is kind of an elongated circle. So Mercury, like all the planets in our solar system, does not orbit the sun in a perfect circle. At its furthest point, Mercury is about 43 million miles from the sun, and at its closest point, it's about 28.5 million miles from the sun. This orbit in the shape of an ellipse with the sun at a focal point. So an elliptical shape is the best way to describe it. It's an elongated circle. And so the equation it looks completely different, I think, than from a circle, but you can see some of the similarities of a circle involved in an elliptical shape. All right, here we go. The ellipse, if you had to technically give the definition of ellipse, it is all the set of all points in a plane such that the sum of the distance from the two fixed points is a constant. And so I'm going to actually go off script here a little bit and try to explain that because I think it is important to understand. So if I have 2 points, fixed points, and I have an elliptical shape here, if I added up the distance between those, so let's say this is, let's do a constant distance of 40. So let's say this is 22 and this one's 18. And so then let's say I went all the way over here, then that constant distance is still 40. Remember, that constant distance doesn't change. And so let's say this is 30, and this is 10. And so if I picked another point, and I'm going to use a different color this time, and I went way over here, maybe that is 34 and 6. So again, it's a constant distance between 2 points. And so if you ever wanted to create an elliptical shape, basically you need a piece of string connected at both ends. And then you just trace, if you've ever traced it on the chalkboard, and I probably will do this when you guys are in class, but it's hard to show right now. But what happens is the actual string itself will always stay the same distance. And so as I go at different lengths here, maybe this is 36 and this is 4 then. So it'll always be a constant distance because the length of the string does not change. All right, so let's go back. There's a lot of different things that we have to come up with here. One is the center. So this is one thing that we'll be talking about, is the center of the elliptical shape. The next one are the vertices. So there's the co-vertices and the vertices. So the vertices on the minor axis. The shorter axis is what's called the minor axis, and the longer axis is what's called the major axis. So these two items right here. And then the foci points. So there are 2 fixed foci points, and those foci points are always on the major axis. The longer axis is where the foci points would be located. So the same thing on the next one. We got the center, we got the co-vertices. Whoops. So I've got the vertices on either side on the minor axis, the vertices on either end on the major axis, and then the center and the 2 foci points. So lots of things that we will have to talk about. Now, it is shown in the picture, but we have to talk about this later. There's a C value. C is the distance. I think it's on the next slide. C is the distance from the center to the foci point. So very similar to P in a parabola, where you have the distance from the vertex to the focus and the distance from the vertex to the directrix. C is the distance from the center to the foci points. So here's all the different ways that we can talk about it, and ultimately it all depends on which way the parabola is going. So x plus h, notice that the first one really stays the same. It's all a matter in elliptical shape is which one is longer. Is the x going to be longer, or is the y going to be longer? And so notice that the center is the exact same in both of these, but the c value is being added differently in the foci. So the C value all depends on which is the bigger one. Is the X going to be the bigger one? Then I add and subtract the C to X. If the Y is the larger one, then I add C to the Y value. And then doubling A and doubling B, again, that all depends on which one is bigger. Is the A value under X bigger, or if the A value under Y is bigger? And that will make more sense as we get into some numbers here. Formula for C. You will need the formula for C. C squared is equal to A squared minus B squared. So you'll have to memorize that particular formula. So P and C are some formulas that we will need in this particular chapter. So here we go. Write the equation. So we're going to start this off by writing the equation. So, oops. So that's what I know about elliptical shape. Ultimately, the center, and I probably should have went back in the previous one, notice the center is very much like the circle. X minus h and y minus k, so the x value of the center and the y value of the center. And then under x is the a value, under y is the b value, and notice both of them equal 1. So going back to the next page here, I had x squared, y squared, I know it's going to equal 1. So what is the center? Well, the center in this case is right in the middle, and we're talking about 0, 0. So you technically don't need that, but obviously the next question doesn't have the center at 0, 0. How far left and right does the elliptical shape go? So it goes 3 to the right and 3 to the left. So under x is kind of like a radius of x. So if I go 3 to the right and 3 to the left, then under x is a 9. Because again, that is a squared. And then if I go up 5 and down 5, then under y is 25. Because that is the y value, or the distance on y, squared. So it's kind of like a radius for x and a radius for y is how I like to describe it. So unlike a circle, which goes left, right, up, and down the same amount all the time, this one goes left and right one distance and up and down a different distance. Next one. So I'm going to go x minus squared y minus squared equals 1. And I didn't give myself enough space to write there. Okay. What is the center of the elliptical shape? So I'm going to find the center of the elliptical shape, or the going on the minor axis and the major axis, and the center is at 4, negative 6. So x minus 4 and y plus, because remember it's the opposite of what's in the parentheses, so y minus a negative 6. Now, how far does it go left and right? So it ends up going 7 to the left and 7 to the right. So under the x, I would put 49, because again, it's the radius for x. And then it goes up and down 6. 6 up, 6 down. So under y, I put 36. Now do it in reverse. Here are the questions that you will have to answer. What is the center? What is the foci points? What is the major axis? And what is the minor axis? And when I say major and minor, I meant length of major and length of minor. Here we go. Center, -1, 2. I highly recommend you go ahead and graph it at this particular moment. So I go to -1, positive 2. The x under x is 4. So that means I go to the right 4 and to the left 4. Under y is 9. So that means I go up 3 and down 3. So there is my elliptical shape. So it's kind of elongated football. With that being said, the major axis, okay, is always the largest amount. So you went up 3 and down 3, or a grand total of 6. You went left and right 2, or a grand total of 4. So the distance across distance on the major axis going up and down is 6, and the distance going across on the minor axis is 2. With that being said, now the foci. In order to get foci, you need C. Here's what I would highly recommend everybody. A is always the bigger number, B is always the smaller number. So I'm going to take 9 minus 4. C squared ends up being 5. C ends up being the square root of 5, plus and minus. What that means now, I am going to go C from the center, and I'm going up and down. The reason I'm going up and down is because the major axis is vertical. So I'm going to go plus and minus the square root of 5 on the y-axis, because again, that is the major axis here. Now I have to do the same thing by completing the square. So this is as tough as this gets. There will be definitely one of these on your test. So I think there's one in which it's already in the correct form and one in which it is not. Complete the square with x. Add 3 squared to both sides. That will complete your square with x. Now for the y, it was a little more complicated. There's an a value. So I have to take the a value out first. Half of 4 is 2 squared, but on the other side of the equation, just like with the parabola, I need to take 2 squared times 4 when adding it to the other side. So I'm just going to rewrite this a little bit further down. So my completed square for x, my completed square for y, and I add everything up there and I get 36. Hyperbolas and ellipses, and today we're talking about ellipses, always equal 1. Well, how am I going to make this equal 1? You do not subtract 35. You actually are going to divide everything in the problem by the number. And so what I end up with, x minus 6 over 36, y minus 2 over 9, because what happens is the 4 and the 36 cancel, equaling 1. So now I have it in the correct form, and so now I can answer my question. Center, foci, length of major, length of minor. So let's graph then first. So I go up here to 6, positive 2. Put a dot. Under the x is a 36, so I'm going to go left 6 and right 6. Sorry that it goes off the graph there ever so slightly. And then up 3 and down 3, which will make my elliptical shape. So the length of the major axis, again, you went left and right 6, so the major axis is 12. Length of the minor axis, which is behind here, would be 6. And now for the foci. In order to get the foci, you need c. C squared equals a squared minus b squared. So I end up getting c squared equals the square root of 27, which is plus or minus 3. Square roots of 3. I will want you to simplify that. And now the question is, do I add the c to the x or do I add the c to the y? You are going to add it to the x value because the major axis goes left and right. So 6 plus and minus 3, square roots of 3, 2. So if you are going to graph that, okay, you are actually going, here's the one foci point and here's the other foci point. I would hit pause on this one and see if you can do this one by yourself. All right, welcome back. Let's see if you can get it. So 16x squared minus 96x plus 9y squared minus 90y is equal to negative 225. So I had to move the 225 over. I'm going to take 16 out of both x's. Half of 6 would be 3 squared. 3 squared times 16. So 9 times 16 is 144. And that would complete the square for x. Take out a 9, y squared minus 10y, plus 5 squared. So on the other side, I take 5 squared times, which is 225, and add all that up. All elliptical shapes equal 1. So I'm going to divide everything in the question by 144. X minus 3 quantity squared over 9. Y minus 5 quantity squared over 16 equals 1. 4 questions. Center, foci, length of major, length of minor. Let's graph it. So the center is at 3, 5. Under the x is a 9, so I'm going to go left and right 3. Under the y is a 16, so I'm going to up and down 4. That doesn't always have to be a perfect square. I know a lot of the examples that I've done so far it is. If it is a square root of a number, just like you did when you were with the radius of a circle. And so my major axis, I went up and down 4. That's the bigger one of the two. So my major axis is 8. I went left and right 3, so my minor axis is 6. And now for my foci. In order to get the foci, I need c. C squared equals a squared minus b squared. So I end up getting c equaling plus or minus the square root of 7. The question is, do I add it to my x or to my y? The y is larger. The y was a major axis, so the foci would be added to the y value of the center. Your homework assignment, now there's not another video for part 2. This is just going to be a practice. So one day will be 13.1 part 1, day 1, and the second day will be 13.3 part 1 and 13.3 part 2. And so there is not a second video, just practice purposes. So good luck. If you have questions, make sure you ask.